All right, guys. I recognize that this math is far above what we have taught you, and so it is going to feel very, very confusing. But what I'd like you to do is just stick with me through this explanation, and it still, I don't think, will be like perfectly clear, or you won't feel perfectly confident to be able to do it again on your own. But we actually will have a stoichiometry unit after Christmas. And so at that point, we'll slow way down and lead you through more of this kind of math, understanding what's happening with these reactions, these equations, in a way that I'm hoping you'll be able to look back on this lab and go, oh, yes, okay, I see how that lab was planting lots of seeds, giving me some exposure for now when we're doing this more in-depth unit about stoichiometry. So I'm going to walk through how to fill out this whole part of the lab up to this part, experimental mass of copper. We did not weigh the copper reactant or the copper product that we had in the filter at the end of the experiment because it was still wet and we didn't have time for it to dry to be able to be weighed. So we are right here at this point where we want to measure the mass of the copper from our experiment that was in the filter. But before we do that, we want to do this, complete this math up to that point. So I'm going to walk you through it. Get out your lab sheet and you follow along with me and just allow it to soak in as deep as it can go for now, knowing that you will get additional instruction later. Okay, when I say additional instruction, I mean we'll do a unit about this later and the pieces will start to come together in a puzzle that makes sense. Okay, so up here, this is the chemical equation for the experiment that we did. We took aluminum and we combined it with copper sulfate in water, and we got aluminum sulfate and copper metal. So if you remember, we cut up those pieces of aluminum, we measured out that blue copper sulfate, mixed it in the water, Lincoln mixed. And then when we drained it through a filter, we had a whole bunch of just little solid particles of copper and an aqueous solution, which was the aluminum sulfate. Okay, so what we want to do here, though, is we want to identify the molar ratio. Now, these numbers, when we've been talking about how this is like two molecules or two atoms of aluminum, right here, 3 molecules of copper sulfate. These numbers can, and here we've got just 1, so there's not even a 1 written, and then 3 copper. So these numbers, they can represent the atoms or the molecules, but they can also represent the moles. 2 moles of aluminum plus 3 moles of copper sulfate plus or are going to produce 1 mole of aluminum sulfate and 3 moles of copper. So those numbers can represent the atoms or molecules, but they can also represent the moles. So when the molar ratio is 2 aluminum, I don't actually know how I'm supposed to fill this out exactly, but I'm just going to say 2 aluminum and 3 copper sulfate produce 1 mole of aluminum sulfate and 3 copper. And so the ratio is 1 copper sulfate or 3 copper sulfates produce 3 coppers. Ratio is a 1-to-1 ratio with the copper sulfate and the copper. Okay, so that's just now some data that will come in handy for us later when we're doing the math. Additionally, this is just a data chart that has the molar mass of copper sulfate. This is just some data that 1 gram, no, 249.72 grams of copper sulfate is 1 mole, 1 molar mat. 1 mole of copper sulfate is this many grams. Similarly, here is aluminum. 26.98 grams is 1 mole of aluminum, and with copper, 63.55 grams is 1 mole. This is just of copper, and this is just a data table. This is just information for us for future use. Similarly, so is this. This is just showing, it's telling us that the starting mass for the reactants in this equation is a 15-to-1 ratio. If we have 15 grams of copper sulfate, then we need 1 gram of aluminum. It's a 15-to-1 ratio. And so these 3 charts are just giving us information. Okay, so what we did is we measured out, here's the data that we started with. We measured out 11.251 grams of copper sulfate. That is what we scooped out of the jar. That is our starting bit. We divided that by 15 to get this 15-to-1 ratio of aluminum, and that's where we got that 0.75 grams of aluminum. So our starting grams up in this equation of how much aluminum and how much copper sulfate came from came from our starting data in a 15-to-1 ratio to get 0.75 grams of aluminum. Okay, so now we get into the stoichiometry, and I want to show you how to fill out. We just need to fill out 1, 2, 3 charts. Okay, and don't worry if it doesn't make sense. Just let it sink in as like the first time that you're learning it, hearing it, understanding it. Okay, so in these boxes, we're trying to do a conversion, and we're trying to convert grams of copper sulfate into moles of copper sulfate. Over here, we're going to be converting moles of copper sulfate into moles of copper. And down here, moles of copper into mass of copper. So the top shows us what the conversion is. And this is setting up like a fraction problem that allows us to come to the conclusion. So we always start with our given number goes into this box right here. And our given number is we're converting 11.25 grams of copper sulfate. So our starting number is 11.251 grams of copper sulfate. That's what goes in that box right there. Okay, now down here, this box is always going to be your given, the units of your given item. This is the given, what do we call it? Your given data point, I guess. Okay, so the units are grams of copper sulfate. Now, what I need to do is create, this is where I put what I want. What I want is right here, convert it to moles of copper sulfate. And what I need to do is, I don't have numbers yet here. I have the unit of my given, and I have what I want. I need to create a ratio that equals 1. So what does one, if I want 1 mole, let's see, how do I do it? Okay, this is where I'm still learning too. Okay, I know that 1 mole equals 249.72 grams of copper sulfate. I know that this ratio is accurate. And here's moles and grams, just like here, grams and moles. So I'm going to use these numbers. I'm going to use 1 mole, and I'm going to use 249.72 grams. 249.72 grams. Okay, so this actually equals one mole of copper sulfate is the equivalent of 249.72 grams of copper sulfate. So these two need to be an equivalent of one another, even though they're going to often be different units. Okay, now imagine this like a fraction where I have this number over 1 times this fraction, this number over this. And those of you who have done your algebra know that you can cancel things out across a fraction. And you can multiply things across. You multiply it across and you cancel diagonally. So I'm going to cancel out this right here, this grams of copper sulfate. I'm going to cancel it with this grams of copper sulfate. Okay, let's see if there's anything else I can cancel. Now I just have this number, 11.251. I have 1 mole of copper sulfate, and I have this number over here. Okay, there's no more canceling that I can do. But so now I multiply across. Ultimately, what that's going to be is 11.251 divided by 249.72. So let me do that on my calculator right here. Okay. 11.251 divided by 249.72 equals, okay, 0.045. I'm doing it to 3 digits because that's what our scale does, is to 3 digits. So 1 mole of copper sulfate is 0.045. Sorry. So what we have in our experiment, 11.251 grams, is the same as 0.045 moles of copper sulfate. Because right here, moles of copper sulfate is the unit that survived this cancellation. And then this divided by this gives us our 0.045. So the conversion of 11.251 grams of copper sulfate is 0.045 moles of copper sulfate. Okay, now we're going to take that number, because look up here. We're going to go into our step 2. We're going to convert mystery number of moles of copper sulfate. It's not a mystery anymore, because the number that we're working with on our experiment is 0.045. We have 0.045 moles of copper sulfate. That's what we measured. And we want to convert it to moles of copper. Okay, let me show you how to do that. Remember that this box is where we put our given number, our converting number. So we have 0.045 moles of copper sulfate. This is where we put the unit of our given thing. So the unit is moles of copper sulfate. We put the unit, but we don't put the quantity. The quantity is going to be whatever is going to be the equivalent to what we want. This is where we put what we want. What we want is moles of copper. Okay, so what numbers in all of this data up here are gonna give us like data that we can input in here? How many moles of copper are going to equal how many moles of copper sulfate? Well, that's where this data up here is. 3 moles of copper sulfate in this equation are equal to 3 moles of copper. So we can put 3 and 3 here. And huzzah, it's all going to cancel out. Okay, so now I'm ready to cancel out and do whatever calculations. So these are going to cancel. This is going to cancel. Actually, that's not what I wanted to cancel. I want to cancel all this over here. Moles of copper sulfate with moles of copper sulfate, and I want to leave this mole still. Ultimately, it doesn't matter. I could have kept this mole instead, but it's okay. Okay, so now I've canceled everything I can cancel out. And now I just, like, all of this is canceled, so I'm just going to multiply across the fraction, and that's a simple 0.045 moles of copper. All right, done with that one. Now I'm going to go down here, and it's going to take this answer and bring it down here. Because now we're going to convert mystery number moles of copper. Well, in our experiment, we had 0.045 moles of copper. So we're going to convert 0.045 moles of copper. Oh, I'm just remembering that Dr. Falconer talked to us about how you should always put zeros before your decimal points so that people don't misread it. I would say that this data table is too tiny to be able to squeeze all that in. Like, I can't fit that right there, but I guess I can squeeze it in. Sure. So if you want to go back and put zeros before all your points, that's fine. Okay, so I took the 0.045 moles of copper. I said, okay, that's what we're working with. And we want to convert those moles of copper into mass, grams of copper. The reason why we want to convert it into mass, the grams of copper, is because then this is the theoretical calculations. Like if we actually started out with this much copper sulfate, this is how all the math works out on how many grams of copper we should have. And then next week, when you actually measure the copper, you're going to compare the actual mass of your experiment to the math of the experiment, excuse me, and see how close your experiment comes to what the math says it should. Okay, so I'm going to take this amount, 0.045 moles of copper. I'm going to put that here because this is the given box. This is the what you want box. And this is the equivalent, equal to 1 and matching the units of your given. So here I go. My given is 0.045 moles of copper. This is matching the units of what I'm given. Moles of copper. There's the units. This is what I want. I want grams of copper. What I want is the conversion right here. I'm converting this many moles to this many grams. So this is what I'm given. This is what I want. Grams of copper. This is the units that match the units of my given. Okay, but now I've got to figure out what to put here and what put to here that would be that would equal 1. And that's where I'm going to go back up to here, and I'm going to find copper, because I know how many grams of copper, it's right here, equal 1 mole. So 1 mole equals 63.55 grams. 63.55 grams. Okay, now I'm going to cancel out. I'm going to cancel out the mole of copper here with the mole of copper there. That's all the canceling I can do. So now imagine that this is a fraction, and this is a fraction, and I'm multiplying these, and I'm just going to multiply across, and that gets, oh, this is where I get my calculator out again. Just a second. Okay, so now I've got 0.045 moles of copper, and I want to figure out how many, okay, times 63.55 grams of copper equals, all right, that equals 2.8 597. Okay, I don't need that many. I want to go to 3, but when I go to 3, it rounds up twice. It rounds up to 2.86. 2.86 grams is the unit that's left of copper. Okay, guys, that is all of the math. This is where you should be. And it may not make a ton of sense, but I promise that as we continue to study stoichiometry, it's gonna become more and more clear. And when you go to class on Friday and you measure the mass of the copper that was in that filter, it should be darn close to this. And if it's not, it's gonna be because of environmental factors or something that I don't know yet. I'm still learning all this stuff with you guys. But okay, if you followed along with me, this is what your sheet should look like going into class on Friday, ready to finish it off with this experimental data. This was when it says theoretical mass of copper. Theoretical meaning like, okay, well, in theory, if we had this much, if we measured this much, and these ratios are all accurate, and this data on how much is in a mole of each, kind of substance, then theoretically this should be how many grams of copper we should have. So that's all the theoretical math, and this is going to be the actual, and you'll get to make that comparison. Okay, good luck. Yeah, good luck. Call me if you need me. Bye-bye.